Hello, let's talk about arterial venous oxygen content difference. And we could really kind of describe this as oxygen consumption by the tissues, because if we compare arterial and venous oxygen, then the difference in the two, that would account for how much oxygen got off at the tissues. And that's basically looking at the CaO2, cVO2, and comparing the difference in those two. The difference is CaVO2 or oxygen content difference, or tissue oxygen consumption. All right, we take a look at one. We say basically that if we had, if we remember the normal values, the arterial oxygen content normal is 18 to 20 volume percent, and the normal venous oxygen content the normal venous oxygen content is about 14 to 15 volume percent. So if we had an example of a CaO2 of 20 and a cVO2 of 15, we just subtract the two and you get an AV difference of 5 vol percent, which is normal. The normal AV difference is about 4 to 5 volume percent. This basically is the math, a reflection of tissue oxygen consumption here. And this is how you would set up the math to do that, but it's simple subtraction. The challenge is to get CaO2 and cVO2, and then once you've done that, then it's just a matter of subtracting the two. If you were to put it in an illustration, remember that arterial, the systemic arteries carry oxygenated blood to the tissues. That's what's pictured here. So I would actually write CaO2 right here, because this is representative of the content of arterial oxygen. And then I would say that the difference between red and blue right here is oxygen being consumed by the tissues. So this is really where tissue oxygen consumption takes place in systemic capillaries. Then over here you have cVO2, and if I take the difference between CaO2 and cVO2, you notice that you're looking at the difference between arterial and venous, and this oxygen consumption, like I said. Okay. Factors that would increase CaVO2. This is a really important point to be made. I want to stress this point, and I want to really prioritize this particular factor as the one main thing that increases AV difference. So if I see an increase in AV difference, then I'm thinking decreased cardiac output. That's one of the main things I would think of. And an example there would be if the CaVO2 started out being 5 vol percent, which is normal, then it went to 6.2 and then 8.5. That's telling me that the cardiac output is decreasing, and that's the most likely scenario. Are there other things it could be? It could be these other things too, but I have this in bold, large letters, and I want you to remember that that's the number one factor. Please remember that. Factors that decrease CaVO2 or oxygen consumption. The main one here is hypothermia. Hypothermia causes less oxygen consumption, and you hear these stories about a kid who falls through the ice in an icy pond and is submerged underwater for 30 minutes, and they're able to pull the kid out and do CPR on them, and they survive and recover and are normal. Well, that happens because basically the tissue's requirement for oxygen is decreased. There's less requirement for oxygen by the tissues when the body's hypothermic. So that's the main factor here. Decreased oxygen consumption is what you have, and that's the issue. Now remember that CaVO2 is a representation of oxygen consumption, and vO2 is oxygen consumption. So those are very similar things, but in different measurements. So the normal vO2, and that should have a dot over it, vO2 is oxygen consumption. That's what that stands for. vO2 is oxygen consumption. The normal is about 250 milliliters of oxygen consumed per minute. So that's another normal value you'll be required to know. Okay, factors that increase vO2, obviously exercise would do that. Seizure, shivering increases oxygen consumption, hyperthermia. You should write fever with this. Fever tends to increase oxygen consumption. The requirements of the body's tissues are to increase the consumption of oxygen, and so you should think about it that way. Decreased oxygen consumption basically is hypothermia again. This is the main one. Okay? All right. Remember that arterial blood gases are a reflection of the lungs' function, while venous blood gases are a reflection of the heart's function. So if I'm looking at PaO2 and SaO2 and arterial side, I'm looking at how the lungs are working. Remember, PaO2 tells me oxygen is diffusing normally. If I'm looking at PvO2 or SvO2 or CaVO2, I'm really assessing heart's function. And if it's deteriorating, if those numbers are decreasing, that tells me a decrease in cardiac output. Now, if PvO2 and SvO2 are decreasing, that's decreased cardiac output. If CaVO2 is increasing, that's also decreased cardiac output. So you have to kind of get those down. I think there's a slide about this. And this says arterial blood gases deterioration tells lung function and lung problem, and deterioration of venous blood says heart problem and some abnormality with heart function. All right, decreased SvO2 is a decrease in cardiac output. That's the main thing to know. An increase in SvO2 is hypothermia. We've kind of been through that. And then this is the statement that I just made. Venous blood gases decreased PvO2 or SvO2 says decreased cardiac output, and an increase in the AV difference says a decrease in cardiac output. It's a lot to take in. Look it over and let me know if I can help you answer any questions. Thanks.